Matter can be divided into substances and or mixtures. So we'll look at those two things here. Substance is matter that has a uniform and definite composition, and there are two types of substances. Elements, which cannot be decomposed into simpler substances. Elements are on the periodic table. So anything on the periodic table, copper, carbon, sodium, oxygen, those are all elements. You cannot break those up into simpler substances. Compounds have two or more elements combined in a fixed ratio. For example, a compound would be like sodium chloride. It's a fixed ratio of 1 sodium to 1 chlorine. Or a compound would be something like water. It's a fixed ratio of 2 hydrogen to 1 oxygen. Compounds can be decomposed into their elements, but we have to go through chemical changes. So I can break up water into hydrogen and oxygen, but I have to go through a chemical change in order to do so. Mixtures, on the other hand, are combinations of two or more substances, but each substance retains its own identity, and the composition can be varied, and I'll get to what that means in just a second. There are two types of mixtures. There are heterogeneous and homogeneous mixtures, which are also called solutions. The first one, heterogeneous. The components separate into physically distinct regions of differing properties. For example, when I put oil and vinegar together, oil and vinegar separate into different phases. So it does not look uniform. They are physically distinct regions. One sits on top of the other, different phases. Homogeneous mixtures, on the other hand, or solutions, have a uniform composition within a given sample. For example, milk, if you look at milk, it is homogeneous. It has a uniform composition within a given sample. But the composition can vary from sample to sample. And what I mean by that is milk, it is uniform, it has one phase, but there are different types of milk. There is skim milk, there's 1%, there's 2%, there's whole milk, and I'm sure I'm missing some others. But the composition from sample to sample can vary, but in a given sample it looks uniform. So that's what homogeneous mixture means. Mixtures can be separated based on their physical properties, and I will demonstrate these three in class, but these are three ways in order to separate mixtures. You can filter them, you can distill, or you can decant. And I will go through more of what those mean in class and show you a demonstration of those three separation techniques specifically for mixtures. So here is what we have. Matter, anything that has mass and takes up space, can be divided into two things. You have substance and you have mixture. A substance can be further divided into elements and compounds. And mixtures can be further divided into homogeneous or heterogeneous mixtures. Okay, so all matter can be classified as one of the four things at the bottom: element, compound, homogeneous, or heterogeneous mixtures. Okay, let me go through each one of these individually. Elements, those are pretty easy to recognize. They're on the periodic table. So if you see something on the periodic table, it is an element. Compound. These aren't so easy to recognize for us just yet, but a compound is a combination of elements, and you can decompose compounds, but these are combinations of elements in a fixed ratio. Okay, mixtures. How do you tell if it's homogeneous or heterogeneous mixtures? Homogeneous mixtures, I'll tell you the easy way that I know how to determine if it's homogeneous or heterogeneous. Homogeneous is either air. Air is a homogeneous mixture, it looks uniform, or something dissolved in water. So I will say anything dissolved in water would be homogeneous. What does that mean? Well, that means like tea, that means milk, that means Kool-Aid, that means salt water, that means sugar water. Anything that you can dissolve in water will look uniform. Okay, so everything else would fall under heterogeneous, and heterogeneous is kind of the catch-all. If it doesn't fall under one of the first three categories, it's heterogeneous. Heterogeneous accounts for 99.5% of the stuff around you is heterogeneous. Heterogeneous has more than one phase. So heterogeneous could refer to, the desk. It could refer to bacon. It can refer to you. They're basically, if it doesn't fall under one of the first three categories, it's heterogeneous. Heterogeneous is kind of the catch-all, and most everything in nature is heterogeneous mixture. So matter at the top, classified as one of the four things at the bottom. All right, let me go through a couple examples here. Liquid A and B are clear liquids. They're placed in open containers and they evaporate. When evaporation is complete, there is a white solid in container B, but there's nothing in container A. So what can you infer? In other words, can you tell if these are elements or compounds or mixtures? All right, first of all, evaporation, when something is evaporated, that's a physical process because you're going from a liquid to a vapor. That's a physical separation, okay? So let's first look at container B because that's the first one listed here, but it says container B, there is a white solid in container B. Well, here's your choices. Element, compound, or mixture. That's your choices for element for the solid in container B. Well, elements cannot be separated. So we can already mark that off because I started with the liquid, I ended up with a solid. So it's not an element because I separated it. Compounds. Compounds can be separated, but they have to be separated chemically, so I can go ahead and mark that one off. It can't be a compound. So the only thing that container B could be, possibly, would be a mixture. It can't be anything else because it was separated. It went from a liquid to a solid. It was separated physically. So that has to be a mixture in that case. Container A, same choices, element, compound, or mixture. Well, in container A, there was nothing left. So basically, whatever was in that container, that liquid, evaporated. Could it have been an element? Well, can elements evaporate? Yeah, they actually can. So it's possible that it could have been an element. Compounds. Can compounds evaporate? Water's a compound. Can water evaporate? Certainly. So it could have been a compound. Can mixtures evaporate? If I have a mixture of vinegar, vinegar is a mixture of acetic acid and water, can that evaporate? Yes. So what can I infer for container A? I really don't know what it was because it all evaporated. So there was no separation that took place. It could have been either an element or a compound or a mixture in this case. Look at one more example. A clear liquid is allowed to evaporate, again a physical process. After 3 days, a solid is left in the container. Was the clear liquid an element, a compound, or a mixture? Well, if it was separated, we kind of went through this on the previous question. It could not be an element because it was separated from evaporation, which is a physical process. Elements cannot be decomposed, so it couldn't have been an element. Compound. Compounds cannot be separated physically. Evaporation is a physical separation, so no, it couldn't have been a compound. Compounds can be separated chemically. So it has to be a mixture because it was separated. It went from a liquid and it was separated. Some of it evaporated, but you left a solid. So it had to be a mixture. My guess, it was probably something like salt water, because if you evaporate salt water, the water will disappear and leave the salt, which is a white solid.